Bismillahir Rahmanir Rahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This is the fifth lecture of testing of hypothesis. In this lecture, I will discuss some important examples of Poisson distribution questions in testing. An important advice: we should be fair to everyone. This question is from June 17, paper 7.3, question 7. In the past, the number of accidents per month. Now, this information will help you to understand that this question is of Poisson because of single events. On a certain road was modeled by a random variable with Poisson distribution, and its lambda is 0.47. After the introduction of speed restrictions, the government wish to test at the 5% significance level whether the mean number of accidents had decreased. This means lambda is less than 4.7, and this is H1. They noted the number of accidents during the next 12 months. It is assumed that accidents occur randomly and that a Poisson model is still appropriate. Given that the total number of accidents during the 12 months was 2, carry out the test. Now, lambda for 1 month is 0.47, and for 12 months it should be let me check the value of lambda, 5.64. So H naught is lambda 5.64, H1 lambda is less than 5.64. You can write lambda had decrease. Here you can write lambda had not decreased, or you can write lambda is 5.64. You have both the options. Now the test value. Because of lesser sign, we have to perform the lower tail test. And test value is 2. So we need this probability. Remember, whatever the sign is here, we always copy that sign here in test value. And the test value is always inclusive. So we need probabilities of these three numbers in Poisson. So probability 0 means e power minus lambda. For 0 write 1, for 1 write lambda, and for 2 we write 5.64 square over 2 factorial. You all know how to calculate probabilities in Poisson. Now this probability is 0.08, or you can say 8%. And this 8% is greater than the alpha percent, which is 5%. This is greater than 5%. That means this is the critical region and 2 is not in critical region, because the probability of less than equal to 2 is 8%, and the probability of critical region is 5%. So you have to say that 2 is not critical region, therefore except H naught. Except that lambda is 5.64, and reject this thing, lambda had decreased, reject this. You have to conclude that insufficient evidence to say that lambda had decreased. That is insufficient evidence to say that lambda, or you can say mean, had decreased. This is very simple. See, you accepted H0. That means when you accept H0, you reject H1. You reject this thing. So it's very simple. When you accept H0, then conclude that lambda had not decreased. I mean, just reject this fact. I mean, you are saying that lambda had not decreased. That is why you are accepting H0. So whenever you accept H0, then write insufficient evidence to conclude that lambda had decreased. The next question of Poisson. This question is from June 17, paper 7.3, question 7. In the past, the number of accidents per month. Okay, I'm sorry, this is the same question. Now, this is the next question. November 17, paper 7.1, question 7. In the past, the number of cars sold per day at a showroom has been modeled by Poisson with lambda 0.7. Following an advertising campaign, it is hoped that mean number of sales per day will increase, meaning lambda will increase, meaning lambda is greater than 0.7. So H1 has a greater sign. In order to test at 10% whether this is the case, the total number of sales during the first 5 days. This 0.7 is for 1 day, and for 5 days. You should assume that the Poisson model is still appropriate. So this is Poisson distribution with lambda 0.7 per day, and for 5 days it should be 3.5, I guess. So H0, H1. H0 lambda is 3.5 and H1 lambda has increased 3.5. Here you can say lambda has not increased. Well, since we have a greater sign here, so we have to perform the upper tail test. And test value is 5. So we need this probability. X is greater or equal to 5. Since we have a greater sign here, so write greater sign here, and test value is always inclusive. So we need a probability of 5, 6, 7 till infinite. And you all know in Poisson we do this in this way. 0, 1, 2, 3, 4. The numbers which are not in this list, we write here those numbers which are not in this list. So 0 to 4 inclusive. So 1 minus e power 3.5. For 0 write 1, for 1 write 3.5, for 2 write 3.5 power 2 over 2 factorial, then 3.5 cube over 3 factorial, and then 3.5 power 4 over 4 factorial. Now this probability is 0.275. In percentage it is 27.5%, which is greater than the significance level, which is I think 10%. So this number 5 is not in critical region. Therefore 5 is not in critical region. This is 10%, and the probability of 5 is greater than 10%. So except H naught. Now you have to conclude this carefully. Since we are accepting H naught, therefore we are rejecting this fact. So say no evidence that lambda has increased. When you are accepting this, then conclude in this way: no evidence that lambda has increased. Or you can say insufficient evidence to say insufficient evidence to say that lambda has increased. You can say in this way: no evidence to say that lambda has increased. Next question. This is normal approximation to Poisson. Very important concept. I will discuss this in my next lecture, inshallah. Good luck and Allah Hafiz.